Hello, in this video we're going to discuss interest rate parity. We're going to do an example problem and derive the formula. So interest rate parity. The difference in interest rates on similar bonds in different countries reflects the expected change in the future nominal exchange rate. So investors should expect to earn the same rate of return in all countries after adjusting for currency appreciation. Example problem. Let's say a U.S. investor has $100 and considering two bonds of similar risk. A U.S. one-year bond pays 10% interest, and a one-year Canadian bond pays 8% interest. Let's say that the spot or current exchange rate, Canadian dollars for U.S. dollars, is 2 Canadian dollars for 1 U.S. dollar. What is the expected one-year future or forward exchange rate? To be indifferent between buying a U.S. or Canadian bond, the future value of the U.S. bond in U.S. dollars will have to equal the future value of the Canadian bond in U.S. dollars. So the future value of the U.S. bond, you buy a $100 U.S. bond, $100 U.S. dollars, and it's going to be just 1 plus the interest rate. So in 1 year, given that the U.S. bond pays 10%, your 100 U.S. dollars will grow to 110 U.S. dollars. Again, reminding us that the spot or current exchange rate is 2 Canadian dollars for 1 U.S. dollar in this example. Let's look at the future value of Canadian bond. So you take this 100 U.S. dollars, and it's going to be multiplied by the spot or exchange rate, which then will be multiplied by 1 plus the interest rate on the 1-year Canadian bond, and that is going to be all then multiplied by 1 over the future exchange rate, where the future exchange rate is going to be F. So the future value of the Canadian bond, after making a substitution here for S, what is S? 2 Canadian dollars for 1 U.S. dollar. Putting in the interest rate for the Canadian bond. We're going to be solving here for F here in a second. So 2 times 100 is 200, and the U.S. dollars, U.S. dollar, U.S. dollar, and the numerator and denominator cancel. And then just 1 plus the interest rate. Simplifying further, the future value of the Canadian bond equals 216 Canadian dollars multiplied by 1 divided by F. So let's set the future value of the U.S. bond equal to the future value of the Canadian bond. So we learned that the future value of the U.S. bond was 110 U.S. dollars, and we just saw in the last slide the future value of the Canadian bond, 216 Canadian dollars multiplied by 1 divided by the future exchange rate. Let's solve this for F. So multiplying both sides through by F, move this F over here, and now dividing it both sides through by 110 U.S. dollars. For interest rate parity at hold, the expected 1-year nominal exchange rate will be 1.964 Canadian dollars will trade for 1 U.S. dollar. So in this example, the Canadian dollar appreciated or the U.S. dollar depreciated to make up for the lower Canadian interest rate. So yes, the Canadian interest rate was a little bit lower, but this was offset exactly by the fact that the Canadian dollar would be expected to appreciate. Again, this is the interest rate parity theory. Let's look at the interest rate parity formula. So just kind of where we left off, future value of the U.S. bond, future value of the Canadian bond, setting both of those equations equal to one another. We'll notice that we can divide through by 100 U.S. dollars. So the 100 USD and the 100 USD on both sides of the equation cancel. Here I'm going to just multiply both sides through by F. And then I'm going to divide both sides through by 1 plus the U.S. interest rate. And we get this formula here. So this is what you see a lot of times in textbooks. So just in general, if you're just looking at foreign and domestic currency, so where the exchange rate, F or S, measures the amount of foreign currency received per unit of domestic currency. And in the numerator here, we got the foreign interest rate. In the denominator, we have the domestic or home country interest rate on a similar type bond. Okay, that's it. I will stop here.